As I said in the last class, that there are some special cases of Raut-Hurwitz criteria, and first case is the case where you encounter zero in the first column. So what's wrong with zero in the first column is that this will result in a division by zero, right? Because we divide by the first column number, right? So then that will be problematic for us. So what do we do? Well, I'll try to explain you through the example, right? So let's take an example. Let's say this is the denominator. I'm equating it to zero because we want to analyze poles. So this is the characteristic polynomial, you can say. It's a very small polynomial. It's a cubic polynomial. Maybe you have the closed form solution for it. You can find the poles also. But since we are trying to use Raut-Hurwitz, so we'll try to use Raut-Hurwitz. Idea is not to find the roots, but idea is to understand this method, right? So I'll start from s cube because highest power of s is 3 here. S cube, s square, s1, s0, as we have learned the method. And coefficient of s cube is 1, so 1, right? Next, I'll look for coefficient for s to the power 1, that is minus 3, so minus 3. S square coefficient is 0, right? So I'm getting 0 in the first column. And then s to the power 0's coefficient is 2, right? So I've got 2 here. So this part, the first two rows are automatically made by just looking at the characteristic polynomial, right? Then I move on to finding the entry at this cell of the roots table, right? So what do I do is, the method is quite simple. You assume this 0 to be very, very small, a small quantity called epsilon, right? And not consider it to be 0, but rather something a very small number called epsilon, right? So as soon as I do this, I can actually divide it by it, right? So what would I be getting here? 2 ones are 2 minus 3 times epsilon, minus of 3 times epsilon, so that will be plus 3 epsilon, right? Minus of this determinant divided by this entry, it is epsilon, right? And so I've got this entry now. Next I move on to, this is 0 because there are two zeros supposed to be here, and determinant will come out to be 0 here, right? Then s to the power 0 power 1, so I'll take determinant of this 4 numbers, so 0 into 0 is 0, minus 2 times this number, right? And I have to take minus of it, right? So minus of 2 times of this number will actually be plus, right? So minus of this and then division by this. So this actually will be equal to 2 only because this part 2 plus 3 epsilon by epsilon and 2 plus 3 epsilon by epsilon will get cancelled. Minus minus will get cancelled and you will only get 2 here. Alright. Now the problem is that how will you ascertain the stability? How will you interpret this table? Right? So you can either consider this small quantity to be positive or you can consider it to be negative. Whichever thing you consider, you will get the same output, same interpretation for the table. So let's say I consider this epsilon to be positive. So you can see the first column signs here. So s cube is positive. I am considering this to be positive, a very positive small quantity. So this is positive, right? Since I have considered epsilon to be positive, this goes to 0 anyways. So minus 2 by something positive, that will be negative. So there is a sign change here, right? And this is positive, right? So there are two sign changes, plus to minus and minus to plus. So there are two sign changes. So there are two uh, poles on the right hand side plane, right? Let's say I would have considered epsilon to be negative, right? Then what would have happened? This is positive, right? Epsilon is negative, I am considering, so this is minus, right? Since epsilon is negative, this is negative, so negative negative will cancel. So 2 by epsilon will be positive, so it again becomes positive, and this is positive only, right? So again you will see that you have two changes, positive, negative, and it again becomes positive. So there are two sign changes in the first column. So either you may consider epsilon to be positive or you may consider epsilon to be negative. Your interpretation of the table will be same, right? So number of sign changes will be 2. So I can interpret that there will be two poles on the right hand side of the S-plane, and therefore the system is unstable. Right. So the other case is case 2, and that is when all elements of one row in the table are 0, right? All elements in one row are 0, right? Now you might be considering that's not a problem because I know how to change the first row, first column 0 to epsilon. I can do it that way, but you should not do it that way. I don't have any logic here for this thing because we have not derived anything here, right? We are just trying to understand some method. So this is all I can say right now because I have not gone into the mathematics behind it, so I cannot comment on why is in Routh-Hurwitz criteria, but you can understand the math, the method behind it, right? So this has to be handled differently from the previous case, right? That is the bottom line. So again, how to handle it? Again, I'll be explaining you by the example rather than writing down the method. So let's say denominator of a closed loop transfer function is this: s to the power 5, 4s4, 8s cube, 8s square, 7s plus 4 equal to 0. Right? These examples I have taken from some book only. You will find them also. Right. So let's say the method remains the same. We'll start with same s to the power 5 से start हो रहा है. So we'll start from 5, 4, 3, 2, 1, 0. Right? Coefficient of s to the power 5 is 1. S cube is 8 and s is 7. Right? So this will be my first row. S to the power 4 is 4. S square is 8 and s to the power 0 is 4. This is what I have got here. Okay. Now how do we find this entry? 8 1s are 8 minus 8 4s are 32, right? Divided by this entry 4 and a negative of it is 6, right? So 32 minus 8 is 24. 24 by 4 is 6, right? Similarly, how will you find this entry? So 4 1s are 4 minus 7 4s are 28, a negative of it divided by this entry 4. So we get 6. This will be 0 here because it is 0 here, right? How will you find this entry? Now 6 4s are 24 here, minus 8 6 are 48, a minus of this divided by this entry 6 is equal to 4. Similarly here we will be looking at 0 into 4 is 0, so 0, minus 6 into 4 is 24, a negative of it divided by the entry here 6 is 4 and 0. Right? So what have we got here? 660,440. Right? So when we come here, what we see is 6 4s are 24 minus 6 4s are 24 is 0. So this entry becomes 0. This entry will be 0 because you have two zeros here, and similarly this will be also 0. So now we have encountered a case where this whole row is 0, right? How will you deal with it? Well, the step one is that you will form an auxiliary equation, and you will form an auxiliary equation using the entries of the row just above the 0 row. So this is my 0 row where all elements are 0, right? Please don't look at this 8 right now. 0 0 0, right? These entries are 0. So you will look at all the entries above this row, right? So you will look at this 4 4 0, right? Using these entries you will form an auxiliary equation. And how will you form the auxiliary equation? 4s square, right? And since this is even row, so 4s square plus this will be 4, right? S to the power 0. So this is the auxiliary equation I have formed. Had this row been the 0 row, तो मैं ये वाली एंट्रीज यूज करता और वो क्या होती 6s cube प्लस 6s, ठीक है। बट अभी मैं इसको यूज कर रहा हूँ क्योंकि ये वाली जीरो है, s to the power 1 वाली जीरो एंट्रीज हैं, so I'll use the entries just above it and I'll form this auxiliary equation, right? Once you form this auxiliary equation, you have to differentiate this auxiliary equation, so that will be 8s, right? ये जो डिफरेंशिएट करके आया, अब आप इससे जीरो वाली रोज को फॉर्म कर सकते हैं, तो दिस इज 8s, सो s to the power 1 की जगह 8 आ जाएगा, बाकी दोनों जगह जीरो, ठीक है। सो दिस इज व्हाट you have to, this is the method, and again I am not going into the logic behind it, the reason behind it, but this is the method that you have to follow. Once you get 8 here, and then this is not a special case, right? Instead of 0 you write 8. एग्जाम में आप ऐसा नहीं लिखेंगे, दिस इज जस्ट फॉर एक्सप्लेनेशन। एग्जाम में as you encounter 0 here, you will do this step and you should write this table again and follow, right, from that, just to make it clear. हाँ, तो फिर अब ये वाली एंट्री कैसे निकालेंगे, तो 0 into 4 is 0, minus 8 4 जा 32, so minus 32, और बाहर माइनस डिटरमिनेंट होता है डिवाइड बाय 8, ये पॉजिटिव हो रहा है। इंटरप्रिटेशन, दिस इज पॉजिटिव, दिस इज पॉजिटिव, दिस इज पॉजिटिव, दिस इज पॉजिटिव, 8 आया था तो 8 इज पॉजिटिव, this is positive, so all are positive, there are no sign changes, so this is a system which has all its poles in the left hand side of the S plane, therefore this represents a stable system, right? And here is where I end my stability chapter. Thank you.